Right, let's go for a start. Nothing. Well, I've got a major problem. The head's leaking. In the back you can see that. I know you can see the drops coming out. Unfortunately, I think it's head off time. Well, that's the head back on. It's all back together again, so let's give it another go. Alright, here goes. I realise what the problem is. I think it's the distributor timing towards post number 1, which is up towards the front of the engine. Well, moving the distributor certainly seemed to work. Running, as you can hear, it's running pretty rough, so now we can just check the timing with the timing marks in the front of the engine. So the red arrow and the white arrow need to line up. Well, it's a bit better. It's running a bit better now that I've retimed it. Hi, welcome back to the channel. Hopefully you've just seen the where I got to previously. It wasn't running at all well at the end of the last video, so got my mate Perry to come over, Perry of Austin 7 fame, and we sort of went through a few things. Yeah, we started by sort of balancing the carbs, seeing if that improved things a bit. It didn't really make that much difference, although there was trouble on one of the chokes. It wasn't seem to be flowing as much as the other. So my concern, I guess, is that the timing's not quite right in some way. So this video is really about checking all of those sort of things. So first of all, I want to do is check that the top dead center mark is as it's supposed to be, and it's marked correctly. I had trouble actually seeing the timing mark, so I'm going to try and improve that so I can mark somewhere else so that I can get a clearer picture of that when I've got the strobe on it. I want to check the distributor timing, make sure that that is advancing as it should, and also giving the right amount of advance, and maybe even the curve is correct. And also I'm a bit concerned that maybe because I took the heads off, that the cams haven't gone back in quite the right place. They may be a tooth out, or maybe a tooth out on the cam, or maybe a tooth out on the crankshaft, although that's a gross difference, and I think that would be pretty noticeable. Anyway, hopefully you enjoy this, and if you did, don't forget, of course, as always, subscribe and like, and sit back and enjoy. Well, we had all the carbs apart. I did, before I put the engine back together and I put the engine back in the car, I did check all the carbs. I took them all apart, cleaned them all out, cleaned all the jets out. Anyway, because we were having problems last time, I've done it again. So, but this time I've actually replaced all of the, I've got a repair kit or overhaul kit, and changed all the gaskets, all the seals, and the little diaphragms on the pumps. But you know, as you know, these carbs haven't got many sort of moving parts as such, and it's all fixed jetting, so I've just made sure that's all clean, so hopefully that will improve things a bit. Well, the first thing is how best to set up or to find top dead center, and also how to time up the cams. Well, as you can see, I've got the bonnet off, and with the radiator in position, you can sort of see that it's not very easy to get to the timing marks. So I'm going to try and make something to make it a bit easier. So whether I can put something on to the existing marks on the water pump casing at the front of the engine there, and extend it across to the outside edge of that pulley. I don't know, so I'm going to do something there because this is no good. Ideally I'd have there would be a slot in that bell housing, and I could pick up some timing off of the flywheel, but that'll be engine out and gearbox out to actually modify that, so I'm not really going to do that at the moment. Maybe next time I've got the whole thing out apart, I'll do that. You see I've got the timing wheel mounted up there at the moment. Maybe I can put a disc and trap that under the bolt that holds the timing, the crankshaft pulley on. just to widen out the flange on that pulley, so I can put some decent marks on there. But what I do need is an indicator, so that needs to be attached to something permanent, fixed to the engine somehow. Anyway, that's the challenge. Well, I made up a pointer. I mounted it on that engine stud there, and as you can see, I've painted the outside rim of the crankshaft pulley with some white marker pen. So now what I need to do is set that up, so I've got it at top dead centre. It's nominally there at the moment because I've used the old V in the inside flange of the pulley. So I've set up the degree wheel on there. I've got a mark at the bottom there, which I can then read the degrees off the degree wheel on or against, and then put the dial gauge up in the on cylinder number 1. So I need to get cylinder number one up onto its compression stroke, firing stroke, and then we can set up the position of top dead centre down here on the pulley, and I'll mark that. But then once I've got that, I can then, and I've got the degree wheel dialed in, I can then mark the various advance positions. So the static advance of 10 degrees, I'll probably put a 12 degree mark on as well, because some settings on some setups need 12 degrees, and then the fully advanced position of 26 degrees. But first I need to find where top dead centre is and mark that. Right, the first thing I need to do is find approximately where top dead centre is. So I'm going to wind this back a bit, and then bring it up onto what top dead centre is. So I've done this before, so it's really where that V mark is pulley. So that's, there we go, that's sort of 0. Right, so now what I do, I turn it backwards off the off top dead centre, anti-clockwise. To a nominal level, and I'm going to turn it forwards till I got a number. So that's 2 millimeters. So I'll leave it at 2.06, say. And now what I need to do is read the degrees off the degree wheel down here, which is sitting at 22 before top dead centre. No, after top dead centre. Now what I do is I turn it past this, back over past top dead centre, so it should come up onto top dead centre, which is about there, and now I need to move it around to 2.06. Carefully. One. Right, a little bit. Yeah, 2.05. That's close enough. So that's on 56 and 57, say 57, 56 and a half. Can't really see that. 57. So that's 57. 57 plus 22 is 9.79. Half of 79 is 39 and a half. So if I turn now, what I do is I turn this back counterclockwise, and I now need to turn it forward so the degree wheel is on 39 and a half. It's 39 and a half. And that should be top dead centre. So let's zero this. That's off. Zero it. 0. What I will do now is check this a couple more times just to make sure it's the right place, and then what I'll do is I'll mark the position on the against the pointer on the outer flange of the crankshaft pulley. So what I'll do first is I'm going to adjust the timing wheel so that the timing wheel is pointing to top dead centre on the degree wheel. So I'll slacken this off and move it round. So that's the wheel moved around to bottom dead centre or top dead centre on that mark. I'm going to leave it like that so I can mark the timing positions against the indicator here. Right, let's just mark top dead centre. That's pretty good. I'm just trying to line it up so when I look at it from the strobe, when I'm looking at it from the side from here, it's actually near the pointer. I might have to bend that pointer down a bit to get that mark. Anyway, that's that done. Now I need to crank this round to 10 degrees and then I'll mark that. So I'll just move this down, checking the timing wheel so it's clockwise. So that's 10 degrees. Mark that one. Oh, I painted the bloody white stuff the wrong side. Right, let's abort that and I'll put some more paint on. Stupid really, because it you can tell by this it's going to go that way. What an idiot. And so I want to mark this and then 12 and then 26. Well, let's let this dry for a bit. Right, let's sit round to 10. There it is, you can see it on 10. And now I'll just mark it on the flywheel pulley. It's 10. Well, let's turn it round to 26 now. Actually, I might do it to 12. Let's just mark 12 as well. Right, that's 12. Yeah, you can hardly see that, can you? I'll just put a dot, I think. There, that's 12. Now round to 26. It's 25, 26. So that should be the fully advanced position. There we are, you can see that it's on 26. I'm just thinking about it, actually the 12 is what I'm supposed to set this up to, it's not 10, it's 12. So I have marked 12, so I'll just extend that mark. So before I try and retime this engine completely and put the distributor back in, I just need to check the cams. So when I had the head off, I obviously put the cams back in, but I'm not sure I got whether they're toothed out, because when I was having problems starting it before, you know, it ran best probably at at 0 instead of 10 degrees advance, which I was trying to set up at that time. It was running better at no advance, just set on TDC. So it may be that the cams are out of time. You know, I think there's one tooth round on the cams, probably not a tooth on the crank. Because I think the tooth on the crank's worth about 20 degrees, and I think a tooth on the cam pulleys is about 10 degrees, which would be consistent with it running better at TDC, set up to TDC, than it would at advanced by 10. Anyway, that's the next job. Timing disc set up on the crankshaft, so I actually know the position of the rotation of the crank at any point. So that enables me now to check the cam timing. Now to do that, I need to find the maximum opening position of the cam, which we'll come on to in a minute. But the you can see here that the crankshaft pulley is a 17 tooth pulley, and that on the camshaft is 34 tooth. So if the cam timing was out because the chain was in the wrong position relative to the cams and the crank, then I don't think it would be out on the crankshaft, because that would be 21 degrees and the timing would be out by 21 degrees. I don't think the engine would probably start at that level of difference. So it's more likely, if there is a problem, it will be a displacement on the camshaft pulleys where the chain may be just a tooth out of position. Now the cams I've got in this engine, it's a big valve engine, so it's the Type D camshaft fitted to big valve engines, and in the Land Sprints and in the Plus 2 S3 130s is what I've got. So the maximum opening position is at the point at which maximum lift occurs, which is just here. But to find that, we need to know the cam timing. So for this, the Type D camshaft, the inlet valve opens at 26 degrees before top dead centre and closes at 66 after bottom dead centre. So to find the MOP, you're going to find the point halfway between those two values. So the inlet duration is shown by that red curve there, and the MOP is calculated by taking the valve duration, which is the addition of the 26, 180 and 66, dividing that by 2, minusing the 26 to give you a position of 110 after top dead centre. Now for the exhaust valve, the exhaust valve is similar but different, because it's obviously in a different phase, but again it opens at 66 degrees before bottom dead centre, closes at 26 degrees after top centre. The duration is the same as the inlet valve, and that gives you an MOP of 110 degrees before top dead centre. So in summary, the MOP for the inlet valve is 110 and the MOP for the exhaust valve is 110. Well, now I'm going to check the timing on the exhaust cam. As you see, I've got the dial gauge set up on the cam. I've made up a pointer on the bottom of the DTI, so that sits on there. When that's about 400, well, the maximum opening is about 400 on that scale. That's 4 millimeters. Got a timing disc on the front of the engine. Sorry about the background noise. That's the builders down the road taking the roof off and putting scaffolding up. And I'll show you the procedure now of how I go about checking the maximum opening position on this cam. Well, the first thing to do is to turn it anti-clockwise and make sure the cam's not pressing on the bucket. So I take it down to a number like that, and then advance it. So this is the direction the engine actually runs in. So I'm going to take it up to about 440, something like that. Remember, the maximum opening position is about 400. So it's going round. And I use a nice long bar because it makes it a bit easier to turn it, because when you get close to the reading, it gets a bit sensitive. Here we go. Like 440. So now we take the reading on the dial gauge. So that is, you might not be able to see this, but it's actually 135 degrees. I lost my pen, so I need to write that down. So 440, 135. And now we continue turning it in the clockwise direction. Yeah, so about 398 was the maximum opening. So now I have to keep turning this around until it corresponds to the same depression on the other side of the cam. So 440. There we go. Oh, that's good. And the reading is, paper's blown away. Right, that's 84. 84. So now what you do is you take the two numbers, so it's 135 minus 84. So that's 51. You divide that by 2. So that's 25.5. And then you add the 84. So that's 109.5, so almost spot on 110, which is supposed to be the maximum opening position. So that's all right, that cam timing's okay. So all I need to do now is really check the inlet. Right, now for the exhaust, the inlet valve. I've set it all up. I've done it a couple of times, and it seems to be okay. So I'll just go through it and show you that it's all okay. Maximum opening position seems to be about, I think it's about 3.4 millimeters on the on this dial gauge. Anyway, just go through it. So let's rotate the. So I'll take it to about 420, something like that. .418, leave it at that. So 418, and what is it down here? It is 75. I'll carry on round. There we go, getting close. There we go. So back to 418, and it's reading 145. This is a bit. There's a bit of compliance in all of this, as you can see. So it's not 100% accurate. When I did it with the engine out, it was much easier setting up the cams than this. I've clamped all this up much tighter, but this will be good enough for a check to make sure it's generally in the right position. Because I was concerned that these might have been a tooth out or whatever when I put it all back together again after having the head off last time. So let's go and do the maths now. 45 less 75 is 72, so half of that is 35, 175, 0, 71, 110, so spot on. As I say, I've done it a couple of times and I know it's all okay, so that's good. So that's both the inlet, we know the inlet cam's timed up right, and we know the exhaust cam's timed up. So I'm going to turn my attention back now, I think, to the distributor, just to make sure that that is properly advancing as it should. Well, one of the concerns was whether the distributor was doing what it's supposed to do, i.e. advancing as the revs increase. I've obviously got it off the car, I've checked it all out, all the bob weights and everything seem to be working. You can take this off and you can see all the weights inside. I've checked they're all moving free, nothing's sticking. And then by turning this, you can sort of see that the thing's not stuck on its shaft and it should be able to advance. One of the things I've noticed is it is a LOTUS control module on this distributor, although the distributor does say made in Germany. I don't know if you can see that. I don't know if anybody knows about these distributors. According to Miles Wilkes, all twin cam engines were fitted with points distributors. So whether this is an aftermarket distributor that's been put on the car or it was a standard distributor, I don't know. If you can leave me a comment, we'd really be interested to know. Well, one of the things I wanted to do was to check the dynamic timing, or the timing on the distributor. So I'll put it up in the vise here, and you can manually turn this plate, and you can see that's the maximum amount of advance it's going to have. By turning this plate, you can see how much advance there is. This body is independent of this. So what I've done is I've made up this degree wheel, little insert, and that just sort of sits in there, and then that pointer, hopefully you can see that, is on there, and then by carefully turning this without moving the whole thing too much, you can see it goes 14 degrees. So that would be alright. According to Miles Wilkes' book, the total advance should be 26 degrees. So 12 static and 14 on the distributor gives you the 26. Well, we certainly checked the timing. I've checked the timing marks on the front of the engine. I've sort of checked the timing on the both cams, and that seems to be okay. I've checked the advance in the distributor. So I think all now remains is to see if it will start. It's all back together again, so let's give it a go. Well, it runs. So all that remains now to be done is to really tune it up a bit. So I need to check the timing dynamically with a strobe, and I need to set the carburetors and just give it a bit of a tweak and then see how it is. Anyway, that's for the next video. Hope you enjoyed this. If you have, don't forget, of course, to subscribe and like, and I'll catch you next time.